Hello, my name is Chen Luigi and my partner is Dvir hashai. We are from the College of Management Academic Studies. Our lecturer is Eliyahu Khalsechi and we are glad to present you our final Java project. The goal of the project is to build maze 3D by using client and server architecture. First of all, we have to build the maze. For that, we use the DFS algorithm or depth first search. In this project, we use the DFS as a construction algorithm, and this algorithm promises a solvable maze. Okay, so now we have to solve the maze, and for that, we use the BFS algorithm or burst first search. This algorithm calculates the shortest route to the exit of the maze. Let's start with the presentation of BFS algorithm. In this algorithm, we use priority queue and set of nodes. For each iteration, we remove from the priority queue the best node, put him inside the set, and check if we are in the end position. If not, searching for successors and join them to priority queue. The successor with the lower cost will join to the set. Another algorithm we used called A star. The A star algorithm based on BFS, and this algorithm is smarter. He used the heuristics of math functions to calculate the shortest way. The heuristics are air distance and Manhattan distance. In this project, those algorithms based on object-oriented programming. We took out the problem and separated it from the algorithm. To make it happen, we used the strategy pattern, taking different kind of maze problems and inject them into different generic algorithms. For example, every maze have a different properties of problems, like the start position and the end position. With this design, we inject the problem to the algorithm.
Hello everyone, my name is Dvir and I will demonstrate you now how the project works. Let's start running the server. As you can see, the server sends a message, server is alive, and wait for communication from client. Now, let's run two different clients and generate them. For each maze, we can choose a different name, number of floor, rows and columns. And there it is, two different generate mazes. To move the character, I just need to press the arrows. The green pipe symbolizes the option to move to the up floor and the red pipe to the lower floor. You can try to solve this maze by yourself, and when you give up, you can press on the solve button and the algorithm will solve it for you. You won! Now you want to save this maze? Alright, let's save it. As you can see, the console remembers your maze name. Now you just need to press the save button and your maze is saved. Now let's open a client and load this maze. And there it is. The server save all the maze it generates as a cache in a zip file. Solution and maze 3D. You check if this maze is already generated before. Send it back to the client and provide service for another client without spending time. When you finish to play and you want to exit from the game, you just use the exit button or press the red X button. Now the client has disconnected from the server, and the server shutting down himself, stopped accepting a new client, wait for all the tasks to finish, and close himself safely. And that's it. Now the architecture. Chen, you can take it from here.
Let's talk about the client side. The client side is the user who connects to the server and asks for a new command. The client designed by three different layers and the communication between them is carried out according to MVP architecture. The client insert command, the view layer defined as observable, and notify all the observers, in this case the presenter layer. The presenter use factory design pattern. It have classes built in for every command that operate function in the model layer. For this example, the presenter receive a generate command and operate the generate function in the model. The model create the communication to the server by using the TCP protocol and sending the client request.
The server side have an algorithm that receive a command from the client and send it to the client handler. The client handler send the command to the server view layer. The server, using the MVP architecture, like the client side, execute the client command and send it back to the client. The client receive his request and deliver it to the view layer to present it on the screen. And just before we say goodbye,